Hello, and welcome to my video for the follow-up to graphical and numerical limits. What this video is, it's an example of a warm-up or a quiz I would give in my class after the lecture for graphical and numerical limits. So let's dive right into this. You can notice on the first problem here, given the following graphs, find the following values. So what we have is two graphs here, one f of x, one g of x. Set of questions here about f of x. So let's take a look at that. So the first one is asking, what's the limit of f of x as x approaches 1 from the right? So you see that little negative sign right there. That is telling us to come in from the left. I think I just said right, but I misspoke. So coming in from the left, and so that's coming in this way. That's coming from the negative side of 1. And you can see that f of x is approaching 3. See, its height right there is 3. So we easily write down 3, and we're on to the next part of the question. Now the next one, let's take the limit of f of x as x approaches 1 from the positive side, or 1 from the right. So that's coming in, following the graph, following the function from the right, and we can see that the value of f of x is approaching 1. All right, so our answer there is 1. All right, and then the next one, notice we don't have any plus or minus here, so this is taking the limit of f of x as x approaches 1 from both sides. And since the left-hand limit is 3 and the right-hand limit is 1, they don't agree, the limit doesn't exist. So we write d and e. Okay, so it's not truly equal to d and e, it's just it doesn't exist. Okay, and then the last piece of this question is what's the value of f of 1? And you can see right there that f of 1, there's a dot there telling us f of 1 is equal to 2. Okay, so this is an example of a question that I often use on a test for the unit. All right, let's move on to g of x. They're asking us to take the limit as x approaches 3 from the left of g of x. So coming in from the left, you can see that the y value, the g value, is approaching 4. So come into 4. Coming in from the right, same thing. This graph is smooth besides a little hole right there at x equals 3. And so that's also 4. Okay, this one's both sides. They agree. So the limit, the two-sided limit, is equal to 4. And finally, g of 3 is defined down here at 3. Okay, so there we go. There's the first part of the problem. Second part's on our new screen. So let's go to that. Now this is asking us to take the limit of sine of x over x as x approaches 0, and the limit of 1 minus cosine x over x as x approaches 0. So it's asking us to do this numerically, so we need a calculator. I'm going to go ahead and bring the calculator over here. If you like, make sure to look up the wabbit.emu emulator for the TI-84. It's really nice to be able to do this sort of thing on. And so let's go ahead and turn on the calculator and go into y equals. And you can see I already typed them in. It saves me a little time. So the first one is sine of x over x. And I have that one turned on. We're seeing the equal sign here of 1 minus cosine x over x. The equal sign is not highlighted, so that graph's not actually going to graph. If we take a look at the graph, see if we can do that, you can see that we have this graph. It's kind of hard to see, so let's take a look at the zoom. Zoom, I like zoom box. It lets us draw a box around what we want to see. So you see the cursor here, it's just off the bottom of the screen. See it moving around there? All right, and so let's start that spot, hit enter, and we'll draw a little box around it, go up and then to the right. If we go up and to the right, we want to encompass that part of the graph. And that looks good. Let's hit enter. You can see we have a zoomed in version of this graph. And you see graphically, it looks like this is approaching x equals 1. But we were asked to do the problem numerically. So to do it numerically, we want to turn on the table. So I'm going to go to second table set and make sure I have my independent variable on ask. So we arrow over to ask, hit enter, and now ask is highlighted. And we're good with that. So now we'll go second table. Since I had the equal sign off on the second graph, you can see we only have a y1, y2 is not showing up right now. So let's try putting in, we want to sneak up on this value of x as we come in from the left, as we come in from the right. So let's show like 3 values from the left. We'll say like negative 0.1. Somehow that didn't work out right. Excuse me. I was using the keyboard instead of the actual cursors on here. So we want to do like negative 0.1. Be good for 1. How about negative 0.01? That'd be a good one. And negative 0.001. My computer's acting very slow here. Okay, and put that one in. You can see we can put it in 0, but 0 is going to give us a error. And then let's come in from the other side. Let's see what, as if we were really close, we'd be at 0.001. Missed one there, so let's try that again. 0.001. 0.01 and 0.1. Okay, and if you look at that, you can see that coming in from the left, get a cursor up here, coming in from the left, 0.1, 0.01, 0.001, all negatives. We're approaching 1. In fact, here it actually gives us a 1 because it's getting so close it rounds off to 1. And then coming in from the right, 0.1, 0.01, 0.001, we're also approaching 1. So you can see our answer is 1. So we can come over to this graph. We can say that's equal to 1. I don't know why that's not writing right now. Let's try it again. So that should be equal to 1. Because I'm not on the right screen. Okay, so that should be equal to 1. But our answer, remember, we have to actually show that we've snuck up on this thing. So this is x, this is sine of x over x. Get that looking a little bit better there. And we're going to put in, you just want to copy what we have on the screen over there. So it's kind of off the screen. I'll show you again for a second. But it's negative 0.1, negative 0.01, negative 0.01, and negative 0.001. And we had 99833, 0.99998, and then it rounded to 1. And then we had actually 0, which gave us an error, so nothing there. And coming in the other way, we had 0.001, 0.01, and 0.1. And those were basically the same answers as above. So it's 0.99833, 0.9998, and actually 1. Okay, so that's the work to back up this over here. All right, then we want to do the exact same thing. So we're done with this problem. We're going to do the exact same thing for this problem. Bring my calculator back. I think I'm going to skip writing this stuff. You guys can copy it down for yourself later. You can always pause the video to be able to get to this. I'm going to go back to y equals. I'm going to come over to this one, turn off the sine x over x, and turn on the 1 minus cosine x over x. So when I go back to my table, again, second table, you can see my answers there. And you can see this actually gives us a different answer. So coming in from the left, we're getting closer and closer to, notice this is negative 5 times 10 to the negative 4. So that's actually like 0.0005. And so you can see that's getting really, really close to 0. So again, you copy down this table. Don't write the scientific notation. Write that as negative 0.0005. And copy down the table. You can see our answer is going to be equal to 0. So let's put that up here. So that's equal to 0. And again, you need to write the table down for the test. You can't just refer to the calculator. But here, since I can put the calculator on the screen, you can copy those down, and that would be the answer to this. All right, well, thank you for listening to this. That video came out a little longer than I expected, but hopefully you'll find this helpful.